What is up guys, this is Luke Hill for Kit Guru and this is the MSI B550 Mag Tomahawk. So the Tomahawk SKU of motherboard from MSI has been pretty synonymous with good value, pretty high spec but reasonably priced offerings, especially on the AMD, so the B450 platform and some of the other AMD options. So can the B550 Tomahawk continue that trend? Notable inclusions for this motherboard are a 10+2+1 stage power delivery solution. You get 2.5 gigabit Ethernet, which is really good to see, and you also get dual cooled M.2 connectors. But let's have a closer examination. If we start off by looking at the MSI B550 Tomahawk itself, and I'm going to watch so I don't drop it, what we can see is that it keeps up with the usual Tomahawk styling that we see. A lot of black, a lot of grey, a lot of silver, and importantly, no orange or red or yellow or anything else that would contrast quite sharply from the underlying aesthetic. I think it's a pretty smart looking motherboard, it's understated, and of course you've got the RGB in the chipset heatsink, which will allow you to tailor the look more specifically to your own preference. Some of the notable points on the front side are obviously, well, the massive VRM heatsink come rear I/O cover, so it basically doubles up. You get obviously some heat sinks for the M.2 connectors. You've got no back plate on the motherboard, and quite frankly it's not necessary really for a board of this caliber. I like a backplate as a premium touch, but it's not a necessity, and MSI is using a 6-layer PCB. If we move around to the 24-pin area, we'll see 4 single latch DDR4 DIMM slots, obviously your usual AM4 memory support. MSI actually highlights support for a 5.1 gigahertz kit in the QVL, so clearly high-speed memory support is an option despite the more affordable B550 chipset being in use. Next to the 24-pin connector, we've got an internal Type-C USB header, and this is great to see. However, this is a bit interesting in the inclusion because it's not 10 gigabits per second USB 3.2 Gen 2, it's actually 5 gigabits per second, so standard USB 3 or whatever the stupid naming scheme is calling it these days is 5 gigabits per second, so slower than some of the competing ports, but at this price point 5 gigabits per second for the internal Type-C header, it's actually quite common. Either way, I'm happy that MSI has included the internal Type-C header. We've seen some of the competitors at this price point have just completely omitted it, which is a bad move in my opinion. And then just above the 24-pin connector, we can see 4 individual boot and post LEDs, and these are useful for troubleshooting. Slightly disappointed to see no onboard or reset or clear CMOS buttons, and there's no 2-digit debug LED, but given the price point, that's perhaps somewhat forgivable in my opinion. If we look at the top edge of the motherboard, we will see that the single 8-pin CPU power connector is nestled in the top right corner, making it very easy to hide the fat 8-pin cable. Notably, it's only a single 8-pin, not 8+4, 8+8 like we see as common, even at this price point actually. But I think realistically, even with a heavily overclocked 16-core 3950X, you're going to be fine with a single 8-pin. Future AMD CPUs might push this a bit harder, but then you're probably going to run into AM4 socket limitations. I'd say for sensible overclocking, single 8-pin's probably fine. And then also along the top edge are 2 4-pin fan headers, another 2 on the right edge, and then 1 of the addressable RGB headers. If we now move along to the SATA area, we'll see 6 ports in total. These are right angled, so easy to hide the cables in a pretty premium case, which you should be using with a motherboard like this. These all run from the B550 chipset, and they do not share their bandwidth with any other components or any other connectors, so that's good to see. And next up, we've got the M.2 connectors. This motherboard provides dual M.2 slots. The top one takes up to 110mm long drives, and the bottom one takes up to 80mm long drives. You get a heatsink on both of the slots, which is a metal heatsink with a thermal pad underneath. Pretty premium. It's good to see dual heatsinks at this price point because some of the competitors only offer you one. The top slot runs from the AMD Ryzen processor installed, so that will be PCIe Gen 4 x 4 with a Ryzen 3000 chip. And then the bottom slot actually runs from the B550 chipset, so that will be a maximum bandwidth of PCIe Gen 3 x 4. And then you also have to remember that the CPU to chipset link is PCIe Gen 3 x 4, so you are likely to run into some bandwidth bottlenecking headaches quite quickly if you're pushing this slot hard, as well as some other high-speed ports like USB. You need to take care when using the bottom M.2 slot because it actually shares bandwidth with the full-length PCIe connector and the PCIe X1 slot above it. There might be an instance where you install maybe a Wi-Fi card in the PCIe X1 slot and this will drop the M.2 bandwidth to X2 link speed, which is pretty slow for modern drives, so be very careful there. In terms of expansion slots, we've got the one steel reinforced PCIe full length slot, and this is obviously for your graphics card. This is PCIe Gen 4 by 16 connection, and it runs with lanes directly from the AM4 CPU. You've got another full length PCIe connector, but this actually runs at up to by 4 bandwidth, and that's Gen 3 from the B550 chipset. So this would be good for maybe a SSD via an add-in card or something like a RAID card or a high-speed network controller. Importantly, however, is that this full-length PCIe Gen 3 by 4 slot actually shares its bandwidth with the PCIe 1 slot above it and also the secondary M.2 slot. So if you install something in the by 1 slot and an M.2 drive in the M.2 slot, this full-length Gen 3 by 4 slot is rendered completely redundant. It cannot be used. And I tested that out by installing an M.2 SSD in the M.2 connector and then installing an M.2 via an add-in card. It wasn't even registered in the system. The bandwidth sharing is highly disappointing. We see competing solutions such as from Asus and the likes sharing the M.2 bandwidth with 2 of the SATA ports. This is far better because if you are reasonably trying to install 3 M.2 SSDs, you cannot do it on this motherboard. You simply can't do it at full high-speed bandwidth. Alternatively, if this bottom M.2 had shared its bandwidth with 2 of the SATA ports, you could have used the top Gen 4 M.2 connection with links from the AM4 CPU. You could have used the bottom M.2 connection with links from the chipset and rendering 2 of the SATA ports redundant but the other 4 usable. And then you could have installed a third M.2 SSD via an add-in card in the full-length PCIe Gen 3 by 4 slot. But on this motherboard, because of the configuration MSI chooses, you cannot do that. If we focus on the bottom edge connectors, you get dual USB 2 headers, and this is great for users of smart AO coolers or RGB interfaces. You get a single USB 3 5 gigabits per second header, and then you've got a few more headers such as fan headers and RGB headers. I will note somewhat disappointingly that some of the headers, so notably one of the fan headers and the RGB headers, are not actually mounted right on the edge of the motherboard. And this is a very minor point, but it does make cable management more tricky because you are looping your cable over some of the PCB. In terms of audio, MSI uses the Realtek ALC 1200 codec, and that's actually a slight step down to the ALC 1220 that we see commonly used on motherboards these days. You also get a bank of Nippon Chemicon audio capacitors for smoothing, and then a dedicated PCB track. In terms of fan headers, you get 8 in total, and 5 of those are within easy reach of the CPU socket. MSI's fan header system on this motherboard is fantastic. 8 4-pin fan headers on a board of this caliber is superb. They're positioned in reasonable locations around the motherboard. I'd say the location is actually very good around the motherboard, despite one of them not being right on the edge. That's a minor point. You get plenty of ability to control the fans very well through the UEFI. So MSI gives you access to a 4-point curve, a 0 RPM mode that actually works properly, and you get some hysteresis settings so you can dampen the changes between fan speed. So overall, I'm very happy with MSI's fan configuration physically on the board and their controllability through the UEFI. And then you've got 4 RGB headers in total. You've got 1 addressable up top, and then 1 more addressable and 2 12 volts down the bottom. Slightly disappointing to see 2 of the 12 volts down the bottom, so 3 headers in total down the bottom. I prefer the 2+2 configuration, especially when you're using an RGB CPU cooler or RGB roof mounted strip in your case. If we shift around to the rear I/O, we will first see that you've got a pair of USB 2 ports, one of which has BIOS flashback duties, and an old PS2 port. Now, as far as I'm concerned, USB 2 is still fantastic to see. Everybody's using a keyboard and mouse, so USB 2 is fine. But PS2, I mean, come on. I think it's a bit old these days. I think, realistically, I would be shocked if many people are using PS2. I would rather 2 more USB 2 ports for more peripherals, quite frankly. You then get 2 5 gigabits per second USB 3 ports, and you get 2 10 gigabits per second USB 3.2 Gen 2, one of which is in Type-C form, and these ports are fed by an AMD CPU, not the B550 chipset. In terms of networking, you get a Realtek RTL 8125, 2.5 gigabit NIC, and that is great to see. I like the high-speed networking inclusion. And then you also get an RTL 8111 backup for 1 gigabit connectivity speeds. Audio outputs are the usual affair, and in terms of display outputs, we get DisplayPort, which does 4K 60, and you get HDMI, but this seems to be version 1.4b. And the reason I say seems to be is because MSI does not make this clear in any of their documentation or on the site. The reason I think it's 1.4b is because MSI highlights support for 4K at 24, okay, a higher than 4K resolution, slightly over 4K, at 24 Hz rather than 60 Hz. So the fact that this is not HDMI 2 when basically every competing AM4 motherboard for B550 is giving you HDMI 2.0, so you can actually run 4K 60 with your upcoming APU, that is ridiculous from MSI. Yes, you might be able to run it at 4K 60, you might be able to do something in the drivers or in the Windows system, or your TV or your monitor and your HDMI cable might support it, but the fact that MSI doesn't make this clear and doesn't officially, by the looks of it, support HDMI 2 is incredibly disappointing. Now this could be a mistake on MSI's documentation, but it doesn't seem to be that way, so this is enough to turn off potential buyers of APUs. And then on a less disappointed approach, there's no clear CMOS on the back. I guess many of the audience for the Tomahawk won't actually need the rear clear CMOS port. If we focus on the CPU power delivery solution, MSI is actually deploying a 10+2+1 stage power delivery solution. So you've got 10 stages dedicated to the CPU, 2 for the SoC, and then 1 for the APU. So the 10+2 CPU plus SoC power delivery solution is managed by a Renesas 22900 PWM controller. MSI does not use phase doublers, so this is running in 5+2 phase mode, and therefore is using a teamed design in parallel operation for the DRMOS. The 10 teamed power stages that are controlled by the 5 PWM controller phases are Intersil ISL 99360 DRMOS power stages. The smart power stages are rated for up to 60 amps of output, and you see them on some of the higher end boards. They're a really smart offering in all fairness. And then in addition to the 10 power stages used for the CPU, you get another 2 of the same Intersil ISL 99360 power stages used for the SoC. So overall, you've got up to a theoretical 600 amps of current capability specifically for the CPU. That's plenty. The high quality components, I'm very happy with the VRM on the Tomahawk. In terms of VRM heatsink, MSI's design is, well, it's basically a big block of metal. It's nothing fancy. There's no real attempt to fin or make a proper heatsink here. But given the sheer size of the block of metal used, especially for the rear I/O cover come VRM heatsink, we're not going to have any cooling problems whatsoever. So MSI is actually quite smart also with the way in which they deploy the two heatsinks, because they're not connected by heat pipes, so they will have to work individually. The larger rear I/O cover VRM heatsink actually handles 8 out of the 10 CPU power stages, so it's handling 80% of the thermal load put through the VRM, and that's pretty smart because there's a far bulkier heatsink with greater surface area. And then the smaller one is managing the 2 remaining CPU power stages plus the 2 SoC power stages. So even though it's physically smaller and not as proficient when it comes to cooling as the larger heatsink, it actually has less heat thrown at it, so it should be fine. And then the heatsinks themselves are not particularly tall. They don't actually rise above the rear I/O cover, so you're unlikely to get much CPU cooler interference realistically. And aesthetically, they look pretty reasonable. And then keeping with the theme of heatsinks, we see that the chipset heatsink is basically just a simple block of metal, and that's fine because B550 doesn't have Gen 4, so it doesn't get particularly hot. The chipset heatsink is also where the RGB LED lighting for this motherboard is housed beneath the chipset heatsink, so it helps to create some shade and some glow from under that block of metal. Anyway, I think that's enough coverage for a closer look of the MSI B550 Mag Tomahawk. Let's jump into the testing. Our test system is based around the Ryzen 9 3950X processor. We use this 16-core beast to really stress the power delivery solution on these motherboards. Cooling the processor is a Fractal Celsius plus S28 Prisma 280mm AIO. We've got 2x8 gig of DDR4 3200MHz CL14 DDR4 memory from G.Skill. Graphics horsepower comes in the form of a Gigabyte Aorus RTX 2080 Ti Extreme with a custom fan speed curve to minimize thermal throttling. We use a Seasonic Prime TX1000 titanium rated power supply for clean power delivery. Our OS SSD is a WD Black SN750 NVMe drive, and we use a Gigabyte PCIe Gen 4 Aorus 2TB SSD for speed testing and games. For testing, we're using the latest BIOS version, and that is version A12. That comes with the AGESA 1002, which is the latest update. If you want more details and further images from the UEFI and a look at the test systems and the comparison hardware, make sure you head on over to the KitGuru website. Let's have a look at the results. CPU-based performance from the MSI B550 Mag Tomahawk is very good. A number of chart-topping results are put forward, with MSI aided by the very recent AGESA update. All-core and single-core boost clocks functioned as expected. Ryzen 9 3950X clock speed after an hour of AIDA 64 all-core loading was 4000 MHz, which is right where we expect it to be. Another set of chart-topping results is shown in the memory tests. MSI's board performs well on both the bandwidth and latency fronts. Again, the AGESA update helps significantly here. Gaming performance is solid and the Tomahawk shows no signs of head-scratching weaknesses. Asus's competitors are consistently faster by small margins, but the MSI B550 Tomahawk holds its own against the Gigabyte B550 Aorus Master. M.2 performance is at the level we expect, with the read result coming in at just below 5 GB per second. Of course, any M.2 SSD installed in the chipset connected slot will be limited to PCIe Gen 3 by 4 bandwidth and any CPU to chipset link speed restrictions. Thermal performance from the metal M.2 heatsink was good enough to keep our drive adequately cooled. SATA 6 GB per second performance from the B550 chipset ports is as expected. Despite using the lower-end Realtek ALC 1200 audio codec compared to the common ALC 1220 used by competitors, MSI's B550 Tomahawk delivers very good overall audio performance, according to Rightmark Audio Analyzer. Manual overclocking is quick and easy thanks to the straightforward MSI UEFI and clear load line calibration settings. Typically we opt for 1.3 volts, but the MSI motherboard was better set with 1.275 volts and Mode 3 load line calibration. This delivered around 1.26 volts under heavy load, a similar level to the competing B550 offerings. Pushing the CPU to 4.25 GHz delivers a strong performance improvement for the B550 Tomahawk when stressed with an all-core load. Overclock power draw numbers were also higher than on competing motherboards, but this is primarily tied to differing voltage and load line calibration settings rather than specific VRM inefficiencies. MSI's powerful VRM solution is more than capable of handling our overclocked 16-core chip with relative ease. Stock clock temperatures were fine for the CPU, despite MSI pushing a little more power through the system than competitors. The VRM heatsink clearly performs well with hefty cooling loads. We did not see the MOSFET sensor rise above 48 degrees Celsius, even with an hour of stress testing in a hot ambient environment at stock clock conditions. Turning up the heat by applying a CPU overclock leads to increased VRM temperatures, but MSI's sizable heatsink still manages to tame the thermal load with relative ease. I'm very impressed by the MSI B550 Tomahawk motherboard's ability to cool its power delivery system proficiently. I must say that I'm happy with the MSI B550 Tomahawk overall. The balance of performance was very good. Overclocking was nice and simple thanks to the easy to use UEFI, well laid out load line calibration settings and strong power delivery solution. The VRM heatsink, despite not being a particularly efficient design, worked very well and kept the power delivery solution cooled proficiently throughout testing. I was very glad to see that there was a MOSFET temperature sensor reading included that fed through data to HW-Info, because it gave us extreme confidence that the power delivery solution underneath was working very well and was handling the thermal load with ease thanks to the big block of metal sat on top of it. And it's good to have dual M.2 heatsinks, which is not actually all that common at this price point. And then another of the quality touches that I was particularly impressed by was the sheer number of fan headers on the motherboard. 8, all being 4-pin with good control through the UEFI, really is very good if you're serious about cooling. Of course, there are some cons with the motherboard. Most notably, the PCIe and M.2 bandwidth decisions by MSI are, in my opinion, not particularly great. I think the competitors do this better. One of the other minor disappointments is that the internal USB Type-C header is only 5 gigabits per second, not 10 gigabits per second. But that's a minor point, and it's quite common at this price point, so I'm not going to criticize MSI too much for that. Where I will criticize MSI, however, is the HDMI port. Now, MSI makes this perfectly clear on their website that it is not 4K 60 capable. They highlight 4K 24Hz or 30Hz support. I would go as far as saying if that does indeed prove to be the case, and the reason I say that is because we cannot test it with an APU because no APUs are currently supported on this motherboard, but for a Ryzen 4000, if it's going to be Ryzen 4000 APU, I would not choose this motherboard if I could not do 4K 60 through HDMI to my TV or my monitor, for example. That's a really bad design decision. And then one of the other minor points is that we could have done with a few more USB Type A ports on the rear. I think that PS2 connection is pretty useless these days, to be honest. And I would rather two more even low bandwidth USB 2 ports just to add some more peripherals into the mix. If we look at the market positioning of the MSI B550 Tomahawk, we see that it comes in at just under £180 in the UK. At that price point, it has competition from the Asus Tough Gaming B550 Plus, and also the ASRock B550 Steel Legend, and they're within about £1 of the price point of the MSI B550 Tomahawk. I think the ASRock B550 Steel Legend is a particularly tough competitor for the B550 Tomahawk. It has many of the same or similar features. It has a strong power delivery solution according to the ASRock website. It has the HDMI port that actually works properly at 4K 60 according to their specifications. It has dual cooled M.2 slots. It has many of the features that MSI offers, but it also makes some of the smarter design decisions with regards to M.2 and PCIe bandwidth that MSI does not. So I think that's a particularly tough competitor. However, MSI's power delivery solution proved very well cooled and well designed in our testing. We also were very happy with the fan configuration from the headers and the actual speed control in the UEFI, and that, in my opinion, is perhaps enough to sway some people down the MSI route, even though the ASRock board is a clearly tough competitor. I will also point out that at the £180 price point, I don't think there are any compelling X570 options that shine a light over the B550 Tomahawk and its competitors on B550. You can get the Gigabyte X570 Gaming X for about £170 or £180 in the UK, but this is not really a direct competitor to the B550 options at this price point. You don't get the high-speed NIC, you don't get quite as good a power delivery solution, so there are some compromises there. So I think from that perspective, I'd say the B550 Tomahawk is pretty well priced for the B550 versus X570 debate. I think overall, the B550 Tomahawk is a good inclusion in the Tomahawk lineup. It does well to offer some of the core features that people want, so strong power delivery solution, good enough cooling from the heat sinks, dual M.2 connectors, both cooled by heatsink. You get 2.5 gigabit Ethernet. So overall, it's a good board that is perfectly fine at this price point. There are some design decisions that are pretty dumb, especially with the HDMI port, if that does serve to be true, and also the M.2 and PCIe bandwidth could have been better. But overall, if you're not using an APU and you're happy with two M.2 connectors, I think you'll be hard pressed to be disappointed by any areas of this motherboard. It performs well, it's solid build quality, and it keeps up with the typical Tomahawk theme. So I've been Luke Hill for Kit Guru. Thank you for watching. Let us know what you think of the B550 Tomahawk in the comment section down below. Is this the motherboard for you? Are you happy with the upgrades versus the B450 Tomahawk? Would you go with one of the competitors? Do you care about the HDMI port? Let us know in the comment section down below. If you like this video, give us a like, hit the subscribe button, do all that YouTube stuff. Make sure you check out the full written article with more details over on the Kit Guru website. And if you want to support us, head on over to our Patreon page and buy a cool t-shirt from our merch store. See you next time.